Hello, everybody. Thank you for being here with us. Thank you to the organizers. This is the second edition of our Security Summit in Lille. Just briefly, we're going to have our first roundtable that's going to be followed by a second Coinbase keynote. And then this afternoon, we're going to have two more roundtables and another keynote. The round tables will be talking about beyond finance. So when we talk about blockchain, we often talk about finance and payment, but there are other uses for it, so we'll talk about them. There will also be a round table on what security represents in terms of finance, of risks, but also business opportunities. To start off this morning, we are very lucky to have two speakers with us to talk about the preservation of digital assets, which is a key issue. Just to give a bit of context, a few years ago, people would buy crypto assets. There were a lot of intermediaries, platforms where they were stocked, and today we can see that preservation is a major challenge. There are an increasing number of assets to protect, so we'll be talking about that. There are different technologies, different good practices as well that we will address. Thank you very much to Thibaut Muriel for being with us here today. Would you like to present yourself briefly? Then we'll start with our discussion and keep 10 minutes at the end of our roundtable. Thank you. Thibaut, I am Director of Security at Defense, an infrastructure defense company within blockchain. And what our company does is create wallets and sign transactions on different blockchains. So we secure private keys by using different technologies. We'll talk about that. And then we also have higher level APIs to interact with the world of the blockchain. And my name is Razi. I work in partnership relations at Zama. Our company allows us to add more confidentiality aspects to public and private blockchains. We have a system that allows us to code together to transform our data on Solidity into encrypted data, Boolean encrypted data, for example, integer encrypted data, and we then can manipulate them without having to decrypt them. So we can execute a code in a public manner without having the underlying data. Thank you very much. My name is Raphael Bloch. I have been a journalist for 10 years, and for 9 years I've been working on digital assets. After working at Reuters and ECHO, I co-founded The Big Well. We're going to be celebrating our 3rd anniversary, and we do a lot of research on digital assets. So Thibaut, a broad question to start off with. Later on, we'll go into more detail. So first of all, can you tell us more about the importance of preserving digital assets? Why is this such a major challenge today? It involves finance, it involves adoption, security. Why do we talk about this aspect to such a great extent? So to start off with, I think that's where the blockchain movement comes from Satoshi, which was created following the 2008 banking crisis. With asymmetric cryptography, we thought that we had the capacity to build a system through which an individual can conserve their own digital assets without depending on a third party that they need to trust. Because if this third party fails, then we have seen that in that case we can then lose access to our funds. This is where it started from. This is where the whole dynamic emerged from, the cyberpunk dynamic. So there was a real awareness, and today people understand that it is important to have access to one's funds and to be able to access them even if all the infrastructures underlying the system is no longer functioning. But a major challenge behind this is security. and we need to feel sure that we can have access to our funds in a secure way. Today there are new solutions, and we'll talk about them later, to decentralize this trust. But we've gone from a model in which we no longer want to have trust in a single entity, because if it disappears, then it impacts us directly. Initially, we thought that each individual could secure their own funds, but that's a problem because there is a lot of fraud. I'm not going to ask my grandmother to write 12 words on a piece of paper and tell her that if you lose that, well, that's the end. Well, in any case, I wouldn't ask my grandmother. I think Web3 right now is in a phase in which we are starting to generate technological solutions to allow us to hold on to this initial notion of ownership, but also keep the trust that we have to make sure that we trust that we're not going to lose all our assets because we've lost a key, because we've lost a piece of paper, because our house burned down, or because our hardware key has gone. So there are several technologies that allow us to preserve our assets. We started off with something that was more self-custody. That means each person conserves their assets for themselves, their own bitcoins. And now today we're talking about HSM, MPC. Could you give us a little overview of the 2-3 major technologies that are used to preserve digital assets? Yes, as I said, the baseline technology is simply a piece of paper on which we write 24 words, but as we explained, this doesn't really work. So behind that, there are existing technological solutions. So HSMs, hardware security modules. These have been tested out. Banks use them. They've been using them for years now. They involve efficient processes and frameworks to ensure their security. These are essentially computers that are highly secure. So even if somebody can physically get access to this computer and try to break into it, it will be extremely difficult for them to extract the secrets that it holds. It is a box in which we hold these private keys and that allow us to generate signatures. Those are HSMs. So it's interesting when you're a bank, for example, well, you're very glad to know that your private keys are securely stored away in a specific place, and then you can add additional physical security and monitoring. That works rather well. You have the ownership, and even physically, you can go and see where your keys are, both for yourself, for your client accounts. We can talk about it later as well. There are additional technical solutions, notably ones on which Zama is currently working, which allows end users, the final retail users, to have access to these secrets in a non-custodial manner. But this concerns banks and institutions. A second point is MPC's, multi-party computations. If you were at the previous presentation, you will have heard something about that. There we have a different security model. We want to remove the single point of failure. We want to make sure that there isn't a possibility to hack a private key in an instantaneous fashion. So with multi-party computation, the private key never exists in one single place in one moment. It's not that there's a key that's broken up into lots of pieces, it's that it never exists in one place as a whole at the same time. We have signers, and these are implemented through pure software. So we have software that each piece of software generates a key share, and then you can say, well, okay, I want to create a cluster of 5 key shares, and I need 3 key share signers who are trustworthy to sign a transaction on the blockchain. So this is a different security model. Here you are decentralizing security and trust. For example, you can say, I'm going to deploy a signer in my bank, and then I have another signer that is at a trusted partner, and then a third one at a third trusted partner. You'd have to hack these 3 institutions to get access to the funds. And this is something that you are developing at Defense. At Defense, we have MPC technology, and now we also have HSM technology. It allows us to create wallets, so we can decide to create wallets in an MPC cluster or in an HSM. So today, this involves an increasing number of companies. They are accessing the sector and there are growing needs. What you have just described is well adapted, and there are choices to be made, of course, between HSM and MPC. But all this concerns companies rather than individuals. Individual people need to have their own ledgers, for example. Isn't that the case? Yes, there are different points of view. They're almost philosophical at this point on this question. Initially, the cyberpunk movement wanted to have a ledger key, the idea being to have a direct ownership of one's assets, one's digital assets, but this can create a problem if we lose or if we lose our ledger, if our finger's cut off, we no longer have a fingerprint, if our key is stolen. So in that case, hackers have access to your private key and they can do what they want. There's no policy, there's not a second validation like your bank would ask. It doesn't work anymore, because in that case, you have the secret that allows you to sign transactions on the blockchain. So there's a real retail demand to try to evolve, develop solutions in which we still keep part of the ownership of our digital assets, but without having this additional problem where if you lose an essential element, you lose access to the whole. The main needs right now concern confidential computing and zero trust, and what this means is that you ask technical providers like Defense to deploy infrastructure, which allows the final user to access a token to identify themselves on this platform and thereby access this secret, this private key on the blockchain to sign transactions. Zero trust means that even we at Defense, as the technical provider, do not have the ability to access these private keys if we do not have the authorization of the user. So this works with secure enclaves, with confidential computing. We give insurance that we cannot access this data without the user's consent. So this is a hybrid mode, which I think we're going towards if we want to have mass use of blockchain technology. Yes, we'll go back to that point. You have described the basic elements here, and then you are on top of that adding another type of encryption on top of that. Could you talk a little bit more about that, where it comes from, why you use this technology? Yes, what I described earlier, the FHE allows us to have operations on encrypted data without having to decrypt them. So a validator is going to execute a smart contract on encrypted input, and they're going to then follow the different stages of the smart contract, obtain encrypted output. And then they're going to have a consensus with the other validators on this output, make sure that the output corresponds to the execution of the smart contract and that this is stocked in the blockchain ledger. So we can now do this in a completely confidential manner. What that means is that the data is public, everybody can see it, everybody can recalculate them if need be, like in all public blockchains. The advantage is that we can do these calculations without knowing on what we're doing them. So we can check that the result is correct by going through all the transactions that we have already done, but those people cannot access my account or my personal transactions. There's a second technology that comes on top of FHE. Now we have zero knowledge proof, ZKP, and this means that at some point we give encrypted data to a smart contract. So as a user, I want to transfer 5 tokens, let's say. So I'm going to encrypt these 5 tokens on my browser and then send it to the smart contract to tell them to transfer these 5 tokens. To make sure that there's no attack, for example, allowing me to copy what Thibault has sent to the smart contract, the user needs to know that demonstrate that they know the value. So they have to send this in an encrypted way through a public encryption, but they have to do this zero knowledge proof to prove that they know the clear value, that he has gone through these stages of crypting. And this allows the smart contract to know that it is really me who is asking, who's behind this, that I'm not simply copied somebody else's actions. Now, the output side is that at some point I'm going to want to know what value I hold. I need to decrypt the values on the blockchain database. And to do that, I'm going to send a decryption request. We use MPC technology to do this, as Thibault described. We do this not for the signature, but for the decryption. So we have 15 knots, and for it, each one is going to verify independently that I have the right to access the data that I want to decrypt, so that my wallet address and ciphertext are in the access control list. If that's the case, they're going to do a partial decryption. So each one of the 15 knots does not hold the full decryption key. So each one is going to do a partial decryption, and each of these partial decryptions are going to come back towards me. I'm going to be able to aggregate them, put them together, and decrypt the worth that I have on the account. So this is how we can ensure that the MPC knots do not have access to my data. This partial decryption also ensures that there's a certain robustness in the protocol. Sort of some of the knots do not function. The system continues to work because there are still 10 other knots, let's say, protecting it. If I could just add to that, what we're talking about here, and what's interesting, I think, is that all of these technologies are going to allow the user to keep their ownership over the data without being directly exposed to the critical secret, the element that allows us to sign transactions on the blockchain. As I explained, once the secret is exposed, there is no control that we can implement to stop funds changing wallets. So exposing the final user to a secret which is not the critical secret, but which nevertheless allows them to have this authorization or this access to data, which then also allow them to sign on blockchains. This is what we need to focus on in our ecosystem. We want to keep this notion of ownership, but on top of that, we need additional levels of security. So today, who are your clients, whether in defense or Zama? Are you mainly working with crypto actors, or is it broader than that? Are you working with native actors? In our case, we are launching our product in June, so we do not have end clients yet, but we have POCs with around 20 different banks. So there are certain have been announced publicly, JP Morgan and Circle. In the end, it relies on a need for confidentiality. So for example, if someone is paying my salary in Bitcoin, I don't necessarily want my salary to be public. So we can remain on a public blockchain while protecting the value of my salary. So let's see if I have a client that's paying salaries in USDC while using a public blockchain, they can still make sure that this transaction and its value is confidential. The idea is that Circle would offer a confidential version of the USDC, and then there are a lot of DIFIs that are part of the payment system. With JP Morgan, it was more about tokenizing assets, securities. So here, the idea was to protect data. For example, if I have an SCPI that I want to tokenize, I can do that without people knowing how many SCPI actions I have. So we were founded in 2001, and then there was the FTX crisis soon after that. There was a major crisis in terms of the image that the blockchain represented. So we began by working with pure players of the ecosystem, of the Web3 ecosystem. So a DIFI company that wants to allow its users to create wallets, for example, instantaneously. Simply by using a Face ID on your phone, you can create your wallet and then use it on the blockchain. So the idea was to offer this kind of experience, make it very easy as well without having to write 24 words on a piece of paper. But in the last few years, there has been renewed interest on the part of financial institutions. And so we have seen many TradeFi institutions increasingly interested in these topics. For the time being, on this particular market, financial institutions want to do custody. So they don't want to offer non-custodial wallets. They don't want to tell their users that they have control over their wallets, but they allow them to buy bitcoins over their platform, and then they're going to conserve the bitcoins themselves. So they need to have a technology that allows them to secure their private keys and sign their transactions. So they're going to use that behind the scenes, but they'll act as custodians. So we're hoping to gain new clients with this kind of system. We've noticed that there has been renewed interest in this field in the last few years. Just to come back on the question of security, there's been this debate about MPCs. Some people say they were less secure. You were talking about the single point of failure, and there potentially could be more of these with MPCs. What kind of guarantees can we bring to banks, to other institutions, in terms of cybersecurity? For MPCs, yes. I think it depends on the type of bank. Banks neobanks like Revolut that are more technological, that work more with new technologies, those types of banks are going to be better oriented when it comes to MPCs. They're not going to have any problem with it. Will allow them to deploy solutions very quickly. At Defense, what we can say to them is, here you go, you take the MPC signer code that we give you, and then you can deploy it within your infrastructure. That way, you have the ownership of the keys, and you can use our infrastructure to create wallets, and you can do that in just a few days. That's a flexible type of deployment that they're probably going to like. But when it comes to traditional banks, now it's understandable because they have whole compliance processes internally that I find very legitimate. And I think that for funds custodies that I was talking about earlier, MPCs correspond less to the model that they have, because centralized trust is not their model. They have invested a lot of money to create private clubs and infrastructures with a private form of security. So if we now tell them, well, you're going to deploy all the MPC signers in the same place, well, for them, in that case, it's better to have an HSM to secure it with that kind of technology that they're familiar with. That's what we are trying to provide. We say to them, you can deploy HSM and MPCs and then transfer between the two of them. For example, your MPCs are going to be hot wallets. It allows you to create deposit addresses very quickly. And that's where retail users are going to place their funds. And then as soon as the funds touch the hot wallet, well, 90% of them are going to be transferred towards an HSM, and those are more cold wallets. It's a bit slower. You need more processes to access those funds, but it is a security model that you are going to be more comfortable with. So I think there's going to be a merger between the two, and in terms of regulation, it's going to become important. We're going to be evolving towards that system. I don't think there's a solution that's more secure than the other. I think for me, it's about what your model is, how you want to use it, and what you want to protect yourself from.
Partage de données.
In the case of sharing data, there's always this question of who you can trust. If you have several banks who want to run a blockchain to share data and run transactions together, the question is who will own the decrypting key. And in HSM, usually the bank owns the key and therefore all the secrets of their customers. But if you have several banks, they won't trust each other, and the MPC remains the only solution that can put all these banks on an equal footing and allow them to work together without giving the trust to one of their competitors. When you talk about trust, there's also an important concept. It's not because you have a software running your infrastructure that you can be sure nobody has access to the software. I own an iPhone, and I cannot guarantee that Apple does not have access to my camera or can activate my microphone, although I have it physically with me. So who is allowed to send a new code into an MPC signer, although it's running in your infrastructure, or who has access to APIs to ask the MPC to run a transaction, is just as important when you build a security model. And often it's a concept that not all people understand. You think if I run the MPCs in my own system, I'm the one with the ownership, but it's not necessarily the case. So in what you're doing, you're talking about ownership of digital assets through a third party, either an existing bank or actors that are starting to emerge rather than individuals. And 15 years ago, the concept was really focused on each individual owning their own key. Do you think we might get back to square one with a blockchain-based system with intermediaries who can take actions that are protected and not visible from everybody? It's a good question. And it's also a technical challenge on our architecture. When you think about it, at the start, the internet's promise was almost the same as Web3. Anybody in their garage can run a computer, plug an Ethernet cable, and get content. But now we realize that if Google pulls the plug, you can lose access to a lot of websites, same for AWS. So there has been a lot of centralization. Will it be the same case for Web3? I think actors like us also have this responsibility to keep this in mind. And as we explained, I think you need to remain flexible. Pushing all security towards final end user, and telling them if you lose the keys, you lose everything, will never work. We need to have a recovery option and keep safety in mind. But to me, what really matters, and I think is important to people, is whether you can have a scenario where a bank, the custodian, decides that you can no longer have access to your assets, your digital assets. That is the scenario that we need to work on. It can be done through MPC, where the bank provides a certain level of security, but if the bank closes or decides that they want to cut my access, I have means to recover my access because there's decentralized trust. So you have a lawyer who has custody of a share of keys, which is not used in everyday life, but if necessary, I can meet a lawyer or another institution and recreate the pattern. So it's really a technological challenge we need to work on. Yes, so there is a regulatory framework that needs to be able to identify fraud cases or money laundering. And as the industry is becoming more mature, if we want to meet the regulations, we will have to give a certain level of access to certain actors such as the police. That's how it works, unfortunately. That's the dream. But we need to prevent funding terrorism or money laundering, so this will always be something to keep in mind. So we're in an adoption phase. I'm sure you keep this in mind, but I guess you're working with companies or crypto native or non-crypto native companies so that they have onboarding solutions. Not everybody will work in a self-custody mode. And those questions of centralization will happen later, just like for the internet. First, we allowed internet to be everywhere. Many people use it. 6 billion people have access to the internet. You think that's this phase now? So we provide flexibility to developers to do whatever they want. They can create smart contracts that can provide a super user the option to decrypt or allow the police to do it. It's up to the developers. It's a smart contract. It's public. It's visible. Everyone knows there's a procedure to detect fraud. And then if the user considers that it's not acceptable, they can decide not to use smart contracts. Other developers won't provide this type of access. We offer the technology, the option to be compliant. Banking institutions will probably be more compliant and others less. About what Isa just said, about the regulation, there are ongoing debates of what a custodian is. Currently, you are a technology supplier. Between a supplier who provides equipment to a company and a real custodian, what's the difference and will that change in the next years? The limit is set by the regulatory framework. The end customer will have to turn to somebody in case they face a problem or they cannot retrieve their funds. That's the question. And this actor will need to be compliant and implement what it takes to be compliant with the regulation. Currently, it's the custodian, and we are the technical solution provider. So we must be able to provide a customer with all the tools and the information they need to be compliant. Logs, data, actions, deployment patterns, etc. But ultimately, it's the custodian's responsibility, legal responsibility. And if there's a problem, they will be liable to their users. and they must be compliant with the regulation. And what we do is we look at the regulation and we make sure that the regulatory obligations are met, and we meet them as a solutions provider, and we provide the right safeguards to our customers so they comply. How about the standards? There are different technologies. Do you think there will be global standards or common rules for all stakeholders? There are a few standards that are emerging. For MPC, there's CCSA. Correct me if I'm wrong, but I think it's an emerging standard. So it's starting to appear. In Europe, there's DORA and MICA, who are implementing a real legal framework with rules when it comes to implementation, and technical providers like us. I think this will naturally create a legal framework, at least in Europe, and if it's successful, then it might be duplicated elsewhere. But we don't have a list of certifications dedicated to digital assets conservation. NIST is on a lower level. We asked for information about MPC. We hope that our system will be shortlisted. Same for HSE. ISO is standardizing HSE, and it's a first step before it's confirmed as secure enough. Because in finance, the banks will start by asking whether the encryption system is good enough or if there's any risk. And what we want to do is reassure them. But we don't face the same issues because we expose public or semi-public data, and we need to reassure enough so they can adopt us without a concern of choosing the wrong encryption system. We can answer a few questions, 2 or 3. Yes? The speaker is not using a microphone for interpretation.
Alors, en fait,
So MPC is a protocol that can allow you to sign in a decentralized manner, as I explained. And the protection against quantum computing is the cryptography algorithm. You can do MPC signing with SCDSA or algorithms, which is already a protection against quantum computing. So it's already working today. There's no technology issue on it. In order to create a quantum computing resisting stack, you need the crypto agility. You must be able to move from a encryption algorithm that can be broken by quantum computing to one that is resistant to it, and actually it runs on this currently. Same for HFE, it's already a post-quantum algorithm, so it's part of the learning with error systems. Doesn't mean you should use HFE to encrypt a database. If you don't want to use encrypted data or manipulate them while encrypted, HFE is an overkill because it's not its purpose. But if your question is whether it's post-quantum, yes, it is. Thank you. Another question? Go ahead.
Alors, le terme n'est pas décentralisé.
So the term is not decentralized, but to permission. So it is a permissioned blockchain, meaning that not any actor can run the nodes of the MPC. We choose them for our customers who run this on premises. So it's closer to a private blockchain. In our case, the difference between public and private blockchain is really about who can see the data. Everybody can see it. It's a public blockchain, but it's a permission blockchain in the sense that there's a limited number of actors who can run the decryption nodes. The technology allows you to add now 15, but later probably a few hundreds. However, you need trust. So we don't think we can let anybody run those nodes because in case of a coalition, it's the same as for public blockchain. If you don't know who runs it, there can be attacks on decryption itself. Thank you. Last question? And then we can have a chat outside.
Oui, c'est une bonne question.
Yes, it's a good question. Bridge and Stripe are not the most complicated when it comes to due diligence for assessment. They have good knowledge of cloud technologies and the flexibility, so they make quite traditional requests, which is SOC 2 security certifications, ISO, and what they call sessions, where I have a discussion with the security teams at Stripe, and I just explain our governance, our security models, and with SOC 2 certifications, we've made the effort of having more than 70 controls, so we can just show them this has been audited by KPMG, and they approved our governance. It's much more advanced when you talk to banks, when you're rolling out codes in their institution, and these are much longer sales cycles. They look at all security certifications and also all the audits you perform, and they have an advanced vision of what the codes can do, if there's security internally for them. But it's not very different from a Web2 actor, at least today. What is the technology stack and how to make sure that it's okay. Great, thank you very much. Please give them a round of applause, and if you have more questions, feel free.